Hi grade sixes, I hope you're doing well. I really miss you and I hope you're staying warm in this really cold weather. Okay, so in today's video, what we're basically going to do is we are going to check what we already know, because often we already know a lot, but you think you don't. Okay, so what we're going to do is I'm going to have the grade 5 textbook with me here, and we're very briefly going to go over what you learned about electricity and electrical circuits in grade 5. All right. I also want you then to write down, because I'm not going to go over it slowly, I'm going to go over it quite fast, and I want you to also try and remember what it is that you remember about electricity, and you will be surprised at how much you actually already know. Okay, so let's have a look at where we started, or what we did in grade 5. Okay, so here I have the grade 5 textbook, and we started with energy and electricity. Okay, then if we page, you can see we started with cells and batteries. We learned what an electrochemical cell was, what a battery was, what a switch was, and what an electrical circuit was. Okay, an electrochemical cell changes the energy from chemicals into electricity. Okay, a battery is 2 or more electrical chemical cells. Okay, so or 2 or more cells. A battery is a source of stored energy, okay, that is made up of 1 or more, actually it is 2 or more cells. Okay, a switch controls electricity in an electric circuit. An electrical circuit is a system that provides a path for the transfer of electricity. Right, and then we looked that a cell had a positive end and a negative end. Okay, we looked at how they fit into a torch. Okay, we also looked at how to dispose of old batteries safely, because remember, especially your alkaline batteries have a very dangerous acid inside them that is not good to the environment if it leaks out, if it is just dumped on landfill sites. All right, next we looked at the electrical circuit. Okay, and I think you guys can remember this very well. Okay, so we had our energy source, all right? Then we had our wiring. There was our switch that controlled it. If the switch was off, it didn't work. If it was on or closed, it did work. The electricity traveled into the light bulb, through the filament of the light bulb, back out and back into our energy source. All right, so hopefully by now I've at least spiked a bit of your memory regarding electricity. Okay, and then you guys remember we built simple circuits. You still did this with Mr. Ludwig, if you remember correctly. Okay, then next we looked at mains electricity, the national grid. Okay, what is an electricity box? Okay, an electricity box is the place where electricity from a substation is connected to the electrical circuits in a building. Right, you will remember that I have one just outside my class. Okay, right, then what is a wall socket? Okay, the part of the wall where an electrical appliance can be connected to an electrical circuit. Okay, a plug. Then we also learned what a turbine is, a big rod that turns with blades arranged like a wheel around it. Okay, so basically like a massive windmill. Okay, and then a generator is a machine that produces electricity. And in grade 6 and 7 we will learn that a generator is not just a machine that produces electricity, because we learn about the law of conservation of energy that says energy cannot just be created or destroyed, it can only be changed from one kind to another. And we already know at this stage that all the energy on Earth comes from the sun. So what a generator does is it changes movement energy, which we've learned about as kinetic energy, into electrical energy. All right, then we looked at the national grid. I'm quite sure you all remember this picture. Okay, we looked at the parts of the mains electricity system, our national grid, the power stations, the pylons and transmission lines, the substations, okay, and then the places where the electricity is needed, okay. Next, we look at how mains electricity gets to the appliances we use. We looked at that you have your distribution box that has all the wiring and the trip switches, okay. Then you have a switch. You plug in your device. Inside your device, the plug is wired like this, okay. So we looked at wall sockets, and we also looked at some of the safety features, how to remove a wall socket properly, how do you know that a wall socket is damaged or not working properly, and what you should do in that case. Next, you guys remember this nice picture that you guys drew so many times, okay, about the whole process of how energy is generated or electricity is generated using coal. Because in South Africa, most of our power stations are coal burning power stations, okay. Right, so what happens is the crushed coal is there, it gets pulverized, which means it gets crushed into even smaller pieces, okay. It goes into the boiler. There the fire heats up water that are in pipes, okay. This water turns into steam. The steam moves very fast because remember you learned about solid liquids and gases, and in gases the particles are very far away from each other and they have a lot of energy. So that steam then turns the turbines, which is like a whole bunch of blades, okay, like, you know, a boat blade or a windmill blade, a whole bunch of those stacked behind each other, okay, and they all turn, and now we have kinetic energy. All right, and that is then connected to the generator, which is the machine that changes the kinetic energy into electrical energy that then sends it to our first transformer, which we learned is a step-up transformer, then sends it along the transmission lines that are held up by the pylons. Right, then there's another substation that contains another transformer that steps it down, meaning it makes the electric current less, okay, or the voltage less, and then it goes into the smaller cables and eventually to the distribution box or the big electricity box on the corner of your block or your street, and then to the distribution box in your house, which is the one that I have just outside my classroom, and when you guys come back you'll see I actually have one in my classroom now, and then into our homes where we have wall sockets where we can plug appliances into them. Right, then we also looked at different methods of generating electricity. We just looked at coal burning. Then we also looked at hydroelectric, we looked at wind turbines, we looked at solar, and remember there were two kinds of solar that we looked at. One where it is a photovoltaic cell, meaning the solar panel itself changes the energy from the sun into electricity, and then another one where they use solar panels or they use mirrors to reflect the heat onto a specific point where they then melt, okay, a substance, which is actually salt, molten salt, and that then acts similar to the boiler. Okay, it boils water, that creates steam, the steam turns the turbine is connected to the generator. Okay, then very important, the next section we learned about was safety with electricity, and I think you guys remember this because I drilled it into you guys. All right, what do you do with plugs and wall sockets? Okay, so there, in this one they say there are 3 important parts or facts to know about electricity. Electricity transmission lines and wires in substations carry large amounts of electricity and therefore are very, very dangerous. Electricity does not go through plastic and rubber. Electricity easily goes through water, people's bodies, and metals. All right. Now, just because it easily goes through your body doesn't always necessarily mean you shock, okay, but you do feel it. Okay, then, how to use electricity safely. So here we have 4 things, okay. The first one was plugs and wall sockets, okay. So do not plug too many appliances into one wall socket, okay. It can cause a fire or an overload. Make sure that you switch off the wall socket before taking out the plug, okay. Hold the sides of the plug to remove the wall socket. Do not pull it by the cord. Also, if a wall socket is not used, make sure it is switched in the off position. Wall sockets are only for plugs. Do not put your fingers or any other objects into the holes. Right, also, if a plug is struggling to come out of a wall socket, you guys know you wiggle it. Okay, you never put your fingers around the plastic part so that you can possibly touch the metal parts on the other side. Okay, then we learned about electrical cords, what you should do with electrical cords, how you should fix them. Okay, I'm just reminding you guys, we learned about water and electricity, okay, and we learned about electricity outside the home. So in this section, we basically learned about how to work with electricity safely. In grade 6, we're more going to focus on building circuits and looking at how we can make electricity do things for us. Okay, like give us light by using a light bulb. Right, so this section of the work that you learned in grade 5 was the national grid, okay, electricity at very high voltages. At school level, whenever we build a circuit, the highest we will go, the highest amount of volts that we will use is 9 volts because that is safe. If I do an experiment and I want to show you something, I might use a 12 volt battery, but then I'll be doing the experiment and you'll be observing. All right. The electricity that they speak about here is minimum 220 and that volts, and that is what you find in the wall socket. All right. In any of these other transmission lines or substations, the electricity is at very high voltages and it is extremely dangerous. So there, it doesn't just shock you, the chances of killing you are very, very high. Okay, right, so next we looked at energy and movement, and here comes in the kinetic energy, your bioenergy, which is the energy you get from the food that you eat. Okay, so we looked at stored energy, how energy is stored. All right, so here we looked more at the sciencey part about energy, how we get energy, what energy can do for us. You remember that cool bird trick, that thing that it looked like the bird was in the cage and actually it wasn't. Okay, then we looked at systems of moving things. All of this still included and was about energy and movement and change and systems. Okay, as you can see, this chapter is, or this section is energy and change and systems and control. Okay, so that's what we basically looked at in grade 5. Okay, so in grade 6, we will be looking more at the different components of a circuit and what these components can do for you. Right, the most common one that we know about is a light bulb. Okay, and for a simple circuit with a light bulb, you need an energy source, so a battery. You need some conducting wire, so energy source, battery, which is a battery, some conducting wires, a switch, and a light bulb. And just with those few things, you can actually make a circuit. Okay, and the light bulb can go on or off. All right, now in grade 6, we're going to look at a few more electrical components. I think last year we did actually look at more. We actually looked at the motor and the buzzer. So these are all other kinds of output that you can have other than light. Okay, so a motor is going to give you movement. Like if you attach a fan to the motor, it'll be a fan. Okay, we've also seen that you can connect a speaker or a buzzer to it, and then it gives us sound. All right, so in grade 6, we're more going to look at the actual circuits. So in grade 5, we looked a lot at mains electricity, and we basically only did the light bulb and the torch of circuits. In grade 6, we do circuits in more detail. And the fun about that is you learn more and more and more how you can connect simple electric components to do amazing things. And how over the years, these components have become smaller and smaller and smaller. And I'm going to hopefully try and show off a bit next week with a video of what we do with robotics, the basics, where we start with the basics of electricity and the electrical laws, and then we build from there. And I want you guys to see that electricity is fun. Electricity is awesome, but you have to know what you're doing, okay? And it's cool to explore with it and to experiment with it. So I'm hoping when you guys come back, we'll be able to do a few practical things. Fingers crossed. But until then, think about what else it is that you've learned that I might have skipped. Page through your book, your textbook, page 113. We are now officially starting with term 3's work. Term 3's work. Ooh. Clearly, it's been a long lockdown. So, read through that, go through it, look at what the different outputs are, familiarize yourself with it, so that when you see me build a circuit, you see, ooh, now she's doing this. Ooh, now this is the output device, or the output component, right? So we have an input, which is your energy source. We have control, which is your switch, okay? Then we have several output devices, okay? An output device is a light bulb or a buzzer or a motor, okay? Things that change the energy, okay? So read through that. I'm not going to give you any other homework to do. If you are interested, go and research electrical circuits. That is, by the way, where robotics started. So I'm quite sad that lockdown took away lateral learning. I had a really cool plan there for you guys, but don't worry, we'll try and figure it out. And if we can't do it this year, I will most definitely do it with you guys next year in technology. So keep safe, keep warm. I miss you guys more than jelly tots, and I love you more than that too. Bye.